Namaskar. Today we will be discussing about a very important topic in the Anthropocene. The topic is greenhouse gases. How it is responsible for causing climate change. How human beings have changed the face of the earth in terms of temperature and so on and so forth. So to start with, if you see the recent report of Indian Intergovernmental Panel on Climate Change has categorically stated that human actions, how they are responsible for causing climate change. If you see, the human actions are estimated to cause around 1 degree centigrade increase in temperature, global temperature, as compared to the pre-industrial levels. So this costs, these human actions are very, very important. And this is called global warming. And this global warming, if you see, it is going to persist for a long period of time, maybe for centuries to millennia. So in that sense, this greenhouse gases emission and climate change is very, very important thing. So today we will discuss about these things in detail. As I told you that human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial levels. Global warming is likely to reach 1.5 degrees centigrade between 2030 and 2052 if it continues to increase at the same current trend. So in that sense, we need to take the measures, and that is the reason why we have gone for a Paris Agreement, which aims at limiting the increase in temperature, global temperature, by 2 degrees centigrade, and will take all the possible measures to keep the temperature increase by 1.5 degrees centigrade. See, when you look at it, this particular graph, if you look at it, the greenhouse gases emission particularly, if you see it, it has started increasing after the industrialization. So before the industrialization, if you see, it was the anthropogenic greenhouse gas emissions were very, very less. But after that, this greenhouse gas emissions, if you see in terms of carbon dioxide or methane or nitrous oxide, it has increased tremendously. The carbon dioxide has increased by 40%, and as far as methane is concerned, it has increased by 150%. And nitrous oxide by, of course, by 20%. When you look at the values keenly, the carbon dioxide concentration when we crossed 1750, it was only 280 ppm, but now we have crossed 410 ppm. So this says that how the carbon dioxide has increased, the concentration has increased, and this increase is mainly because of the human action. And second important gas I just mentioned about is the methane. So when you talk about the methane, present concentration is around 1.8 ppm. But then, before the industrialization, it was only 720 parts per billion. And this increases very much because it is, I said, it is 150%. When I say 150%, it's too much. Because this 150% is because of the human action. And what all the actions that has led to the increase in the methane concentration, we'll see in few minutes. And the third important gas as far as the greenhouse gas is concerned, it is nitrous oxide. The nitrous oxide concentration is 320 parts per billion, but then it was only 270. So the increase was not much. It was around only 20% increase as far as the nitrous oxide emission is concerned. But these three are very, very important gases: the carbon dioxide, the methane, and nitrous oxide, which is a footprint. It acts as a footprint or an indicator of how human action is responsible for causing climate change through increase in greenhouse gases. See, when you look at the economic sector, in the year 2010, the IPCC report categorically stated that how much we are responsible in releasing greenhouse gases emission into the atmosphere. It comes around, the data states that it is around 49 gigaton carbon. It is released per year, every year. And the sectors, economic sectors, if you look at it, is the energy sector, which is contributing maximum around 35%. Thereafter followed by agriculture, forest and land use sector, and this sector contributes around 24%. Industry contributes around 21%, and the building sector, building and construction sector, contributes around 6%. But if you take into account the indirect emission also, then the industry's contribution will be 31%, and the building and the construction sector will be contributing more than 19%. So in that sense, we can see from this particular graph how important the greenhouse gas emission, the portfolios that have been given, and which sector is causing how much, it will be known. And this particular graph is important from the perspective of management, how well you can reduce the greenhouse gas emissions. Either from the energy sector or industry sector, we need to look at the different trajectories of development pathway. In that sense, it's very, very important. This graph is important, and also to categorize that 49 gigatons of carbon dioxide equivalent is released per year because of human action. And now we'll see the greenhouse gases. As I said, these greenhouse gases are radiatively active gases. They absorb terrestrial radiation, long wave radiation, which is more than 4 micrometer. And these gases are called as greenhouse gases. And these gases are radiatively active gases. It means that it is having an ability to absorb the long wave radiation that is emitted from the Earth's surface. And these gases, because of these gases only, the present temperature, the Earth's temperature is 15 degrees centigrade. It is because of these gases only, through an effect called greenhouse effect. If the gases or greenhouse gases are not present, then the Earth's temperature would have been minus 19 degrees centigrade. Now the temperature of Earth is 15 degrees centigrade. So this greenhouse gases, through an effect called greenhouse effect, contributes around 34 degrees centigrade increase in temperature. So in that sense, it's very, very important thing. It's very, very in a way, made the Earth livable. But the present day concentration, if you look at it, just now I mentioned about the carbon dioxide concentration or nitrous oxide concentration or a methane concentration or many other radiatively active gases like perfluorocarbons, chlorofluorocarbons, SF6. There are many. Tropospheric ozone is also there. So there are many gases are there. The present day concentration is remarkable. In a way, I say remarkable, it means that never ever in the history, in the past history, if you look at it around past 8 lakh years, this concentration has never occurred. So it's very, very alarming. Alarming means that how well we can take measures to manage the climate change or how well we contain the increase in greenhouse gases emissions. So we have to look at the management aspect from the gases perspective. What are the gases? Second is, what are the sectors contributing the greenhouse gases? So in that sense, we can achieve the goal of reducing the global temperature by 1.5 degrees centigrade, because the effect caused by climate change or global warming is irreversible in nature. And the effect will be occurring for millennia, even though if we control at this stage, if we start controlling the emissions of greenhouse gases, then also the effect will be noticed. And because that is having a very irreversible effect, and it will be affecting all the components of the climate system. So in that sense, many of the organisms, many of the species will be affected. So the first important gas is the carbon dioxide. This carbon dioxide is a very, very important gas as such, because if you look at it, is that it's a prime gas. It contributes much more than other greenhouse gases, the global warming. The concentration, or in other words, the measurement, precise measurement started in the year 1957 in South Pole, and in the year 1958 in the Mauna Loa, Hawaii, the carbon dioxide concentration was started measured. And when you look at the measurement from since 1958, we have a proper and a precise measurement. And thereafter, if you see it, the rise is very steep. The trend is very, very steep. And in that sense, we need to take a lot of measures. So now the present concentration, as I told you, it is 406 ppm to 410 ppm. The concentration of carbon dioxide, now it is 410 ppm. Before industrialization, it was just 280 ppm. So this increases around, I said, it's 40%. But now the concentration, the magnitude of carbon dioxide is very important. Second is how the increase, the growth rate. See, in the year 1950s, 1957, 58, the growth rate was around, for example, it was very less. Now it is 2 ppm per year. It is increasing. And then it was very less, 1 ppm. But now it is increasing by 2 ppm. Every year it is increasing. And in that increase, we need to take measures to contain the carbon dioxide emission because of the human action. Second important point, as far as the carbon dioxide as a greenhouse gas is concerned, in the atmosphere, the content is 800 gigaton carbon. And on the Earth's surface, on the vegetation, it is having around 690 gigatons of carbon. It is present in the vegetation, terrestrial vegetation. But as far as the main part in the climate system, if you look at it as the carbon that is present in the oceans, 390,000 gigatons of carbon is present in the ocean. So in a way, what I want to say is that the sink lies in the ocean and the vegetation. So whatever management practices, whatever the principles we need to take into account, we need to focus on the two things. One is the ocean, the other one is the vegetation. How to sequester the carbon from the atmosphere and store it deep inside the ocean or else the vegetation. by through carbon sequestration or biosequestration. These are very, very important thing as far as the dynamics of carbon is concerned, and of course the global carbon cycle is concerned. The second important point is the sources of carbon dioxide in the atmosphere. When you talk about the sources of carbon dioxide in the atmosphere, the foremost source is the fossil fuel combustion. The fossil fuel combustion is the foremost important thing, because the carbon rich material or the biomass, it is burnt immediately after the industrialization, and that is the prime reason for increasing the carbon dioxide concentration in the atmosphere. And second important cause as far as the carbon dioxide is concerned, it is a cement production. Cement production also releases a lot of carbon dioxide into the atmosphere. And the third important thing that we need to focus very closely, keenly, is the land use changes. Land use changes also, either because of the agriculture, urbanization, or many other activities. Land use changes also contributes to carbon dioxide, and that, in fact, we are pumping more of carbon dioxide through these three important processes or human activity into the atmosphere. So the focus will be on these sectors: the combustion, the fossil fuel sector, the cement sector, and land use changes that we need to take into account. Next important point as far as the carbon dioxide is concerned, if you look at it as whatever we are emitting in the atmosphere, most of the things has been sink. It has been taken by the vegetation or the ocean. But 38% of whatever we are emitting into the atmosphere, that is left behind in the atmosphere, that we called as airborne fraction. So 38% of whatever we are emitting into the atmosphere is left in the atmosphere itself. So this 38%, how to remove it from the system, and there lies the policies. There lies the strategies, the mitigation strategies, how to reduce the carbon dioxide concentration in the atmosphere. And next important point is that we need to adapt ourselves. The system has to be adapted. Whatever the system, ecosystem, whatever the system is there, we need to adapt itself to the change in the temperature because of the change in the greenhouse gas emissions. So airborne fraction is 38%. And as far as the carbon dioxide is concerned, we need to understand that at what wavelength these gases are absorbing. So carbon dioxide as a greenhouse gas, it absorbs terrestrial radiation at 2.7 micrometer, 4.3 micrometer, and 15 micrometer. So these three bands are very, very important thing, because it lies in the atmospheric window, and at these three bands, the carbon dioxide as a greenhouse gas, it absorbs the terrestrial radiation, and this absorption is causing the increase in temperature, exactly the global warming. So next we'll look at the other gases. The next important gas is the methane. As I told you that the concentration of methane has tremendously increased after industrialization. Now it is 1.8 ppm. Earlier, before the industrialization, it was 750 parts per billion. Now it is 1.8 ppm. And the main source is the cultivation of paddy. Second important activity that we need to take into account is the livestock. The ruminants, because of the fermentation that is taking place in the digestive system of the ruminants, also releases methane. So this methane, if you see, it is again a carbon compound, and it's very, very important thing, because the global warming potential, when you look at the methane as compared to the carbon dioxide, it is around 30 times more powerful, potent than the carbon dioxide. And third important source as far as the methane is concerned, it is the waste management, landfills, manure management. These also releases methane into the system, into the atmosphere. So these three sources are important: the rice, the paddy cultivation, the second is the livestock, and the third is the landfills. So in a way, these three gases, the carbon dioxide, the nitrous oxide, methane, is somewhere related with the food production, somewhere related to the security of the citizens in terms of food, in terms of nutrition, in terms of all other aspects, in terms of the sustainable well-being also. So we need to take into account all these things when we discuss the greenhouse gases, and in relation how best we can manage, we can achieve the sustainable development goals. So next important point as far as the methane is concerned, we need to understand that this particular methane gas, greenhouse gas, absorbs the terrestrial radiation at 7.7 micrometer. And when you look at the residence time, atmospheric lifetime, this particular methane is having around 9 to 15 years. It is having the residence time. Atmospheric lifetime is very, very short. In that sense, our mitigation or the adaptation, we need to take into account the atmospheric lifetime of methane, which is very, very less as compared to other gases like nitrous oxide and many other gases. The chlorofluorocarbons also. So the residence time as far as methane is concerned is very, very less. It is between 9 to 15 years. A very important point I wanted to stress here is, as far as the methane is concerned, is that how well we can remove methane from the atmospheric system. And it is very much possible with a compound called an hydroxyl group. In fact, this methane reacts with the hydroxyl group and it is converted to carbon dioxide and many other gases also. And in that way, what happened, in addition to being a primary greenhouse gases, methane is also causing a secondary effect. It will have a secondary effect on climate change. When I say secondary effect, because the methane will interact with hydroxyl group and releases ozone. Ozone is a potent greenhouse gases. It's a tropospheric ozone. It is a potent greenhouse gas. So in that sense also, this reaction of methane with hydroxyl is very, very important thing. Another compound that is released out of this reaction between methane and hydroxyl group is the water vapor. Water vapor, we know it's a very, very important greenhouse gases, and it's very, in that sense, as far as the tropospheric water vapor is concerned, it will not be causing any harm. But if it is in the stratosphere, it will be a great concern. So these two important points has to be taken into account as far as the indirect effects of methane. How best we can manage it, we need to take into account. And when you look at the reaction, the methane plus the hydroxyl group, it releases the carbon dioxide, ozone and water vapor. If the concentration of hydroxyl group in the atmosphere decreases due to this reaction, what will happen? This reaction between methane and hydroxyl group will drastically reduce. If that happens, the atmospheric lifetime of methane will be increasing, and this increase will be causing more of global warming. And in other words, the global warming potential of methane will increase when the hydroxyl group or hydroxyl concentration in the atmosphere decreases. So these are very, very important thing as far as methane is concerned. Very related thing as far as methane is concerned, if you see deep below the permafrost region, this methane is present. And because of global warming, if this permafrost is melted, what will happen? The methane will be released from the Earth's surface, and this will have a positive feedback. This will have a positive feedback on global warming, and in that sense it's very, very important thing. And also when you see, because of the melting, what happened, there will be a lot of organic matter decomposition, anaerobic decomposition. If that will also lead to increase in the methane concentration in the atmosphere. So these are all the points we need to take into account as far as methane is concerned, and we will look at the strategies later on. And next important gas is nitrous oxide. The nitrous oxide concentration is not so higher, but still it is very potent greenhouse gas, for a simple reason that the global warming potential is much, much higher than the carbon dioxide, and the present day concentration is 320 parts per billion. And before the industrialization, it was only 275 parts per billion. Now it has increased by around 20% to 320 parts per billion. And the nitrous oxide concentration in the atmosphere is mainly because of human action. And particularly when you look deeply into the nitrification part of the nitrogen cycle, if you see, the nitrification is a microbial mediated process wherein the ammonical nitrogen will be converted to nitrous oxide. But this nitrous oxide as a greenhouse gas we need to take into account deeply, because the nitrification process is because of microbes, first thing. Second important thing is that this nitrification or nitrogen source is mainly due to the nitrogenous fertilizers. The other sources for nitrous oxide emission in the atmosphere are the forest clearing and the combustion. If you see in the catalytic converters in the car also, that may also result in nitrous oxide emission in the atmosphere. So these are the three important sources responsible for increasing nitrous oxide emission in the atmosphere. And when you look at it, is that as far as the sink or the degradation of nitrous oxide is concerned, it will happen only in the stratosphere region and through a process called photolysis. And Otherwise, in the troposphere, there's no sink is there as far as the nitrous oxide is concerned. And as far as the absorption of terrestrial radiation is concerned, it absorbs at 7.8 micrometer and 8.6 micrometer. It shows that how best the bond angle is stretched at 7.8, and there will be bending of bond angle at 8.6 micrometer. And just because of this reason, the absorption band is shown at 7.8 and 8.6 micrometer. So when we have seen the three important gases, the carbon dioxide, methane and nitrous oxide. And now we have to look at it other aspects when you see the management aspect. And as I told you that these three important gases are released mainly because of human action, and particularly the land use changes are very, very important thing. When I talk about land use changes, agriculture is the prime important thing. See, as far as agriculture is concerned, 40% of Earth's land surface, it is covered by agricultural activity. And the change that we have human beings have caused, if you see it, 40%, believe me, it's 40% of land surface is agriculture. In the last 10,000 years, if you see, we have changed the landscape of Earth through agricultural activity. Of course, it's a very important thing because it is helping to increase agriculture production, and by that way, we are in a position to feed 7.2 billion population. By 2050, we wanted to feed 10 billion. So what we need to do, we need to manage the sector from the perspective of food security, from the perspective of nutrition security. And also, as I told you that the land use changes, or in other words, agriculture is also responsible for releasing a lot of greenhouse gases. I said it is around 24% of greenhouse gases that we are seeing in the atmosphere is because of agriculture and related activities like maintaining the livestock, ruminants, and many, many other things also. So we need to take into account that agriculture or land use as such in management. So when you see, agriculture can be managed very well through a lot of interventions, agriculture interventions, because from every sector, from every activity, agricultural activity, it is somewhere releasing a lot of greenhouse gases into the atmosphere. So for that reason only, new approaches have come up lately. If you see, a very important approach, that is the climate smart agriculture, which is a very, very important thing, because whatever the agriculture interventions we are talking about, which is having a very positive effect on the environment, in terms of the climate change mitigation and adaptation is concerned, this climate smart agriculture takes care of very well, because it factors in three important principles. One is the measures or the agriculture intervention, whatever the technology is concerned with the climate smart, it focuses on what? It focuses on reducing the greenhouse gases emissions from the agriculture. And second important point is how best the agriculture can be adapted to the change in the climate. That's a very important thing as far as the climate smart agriculture is concerned. And third important thing is, as I stressed, very important is whatever the agricultural activity we are doing it, we are aiming for food and nutritional security. These three things are very much possible through climate smart agriculture. And this climate smart agriculture is having another, good virtues. One is the landscape approach. It focuses on the landscape. It is an integrated approach. It focuses on the landscape. It is not only local specific, it is not location specific. It takes into account the landscape. In a way, what happened, landscape management will have a very, a very protective and productive role to play. And this landscape approach, when you see, is definitely a bottom to top approach. When you say bottom to top approach, what are the farmers, whatever they are on the local level, they may have their own technologies. They may have their own indigenous knowledge. Everything will be factored in to make this climate smart agriculture a very successful phenomenon as far as the agriculture is concerned. This climate smart agriculture, it has grown very widely. If you see the global area, global landscape, agriculture, the large extensive farmers, they are practicing climate smart agriculture. But one important point as far as this is concerned, this climate smart agriculture is concerned, we need to take into account that why this climate smart agriculture is not extensively practiced by smallholders, small scale farmers. They are not practicing so extensively. So what is the reason? So there will be definitely certain obstacles, certain constraints. The constraints can be knowledge. It can be the incentives. Incentives means in terms of money, in terms of the insurance, in terms of the government support, in terms of many, many other factors that is, acting against this absorption of this technology. So this is a very important thing we need to take into account. We'll see in 1 or 2 minutes about what are the obstacles the small farmers are facing in absorbing the climate smart agriculture, the practices. So in that way, because we see all the positives are there as far as climate smart agriculture is concerned, but still the small farmers are not practicing. As far as the mitigation is concerned, so when you see, I told you that the paddy cultivation is a very, very important activity that is releasing more of greenhouse gas emissions. So whatever the paddy cultivation, rightly if you see, we are going for lowland cultivation. In that sense, we need to have a mitigation strategy. What we can do, we can go for a system of rice intensification, so wherein there is an increase in the efficiency of water use. There is an increase in the efficiency of the gases, greenhouse gases that is emitted into the atmosphere. So in a way, if you see that there is a lot of approaches, there are a lot of positive approaches that is there inbuilt in climate smart agriculture. So this climate smart agriculture, as far as the land use practices, as far as the agriculture and land use the related sectors are concerned, is very important thing, because it also takes into account the livestock also. How best we can maneuver the feed stocks, how best we can factor in more of proteinaceous compound, proteinaceous feed. So in that way also the greenhouse gas emissions from the ruminants can be curtailed, that can be very drastically reduced. So this is all about the climate smart agriculture. It is having a very, very positive thing. But as far as the whole concept of greenhouse gas emissions today, we have seen, see, this concept of greenhouse gases emission is a very important thing, because we have learned quite much about the global cycle, the carbon cycle, and many more things. But this lecture on greenhouse gases are very important thing, because we have just sorted out the sources and what particular mitigation strategies, because when you know the sources, definitely we can have the mitigation strategy also. So what we are running for, we are running to how to reduce, how to keep the increase in the global temperature at 1.5 degrees centigrade. We are trying very, very hard, because the Paris Agreement states that we need to keep the increase in temperature at 2 degrees centigrade. But our measures will be to keep the temperature increase by 1.5 degrees centigrade. And this is possible only when we can categorize, only we can know exactly the greenhouse gases that is present in the atmosphere and what are the resources also. So in that way, what happened, the potential of managing how best we can achieve the 1.5 degrees centigrade lies in the quantum or magnitude of carbon dioxide and other non-carbon dioxide concentration, non-carbon dioxide greenhouse gases are concerned. So the measures, the policies, what we need to understand, we need to understand the mitigation policies. The mitigation policy will be focusing on the energy sector, on industry sector. And as far as the non-carbon dioxide greenhouse gases are concerned, definitely the three important gases are there. Methane is very, very important thing. Nitrous oxide is very important thing. So the targeted mitigation policy is very, very important thing. In agriculture sector, it's very important thing, because when you have a targeted mitigation policy, definitely that can help in reducing the methane emission or nitrous oxide emission from the agriculture sector. So in nutshell, what I want to say is that the greenhouse gases emission, it's drastically increased just immediately after the industrialization, because of the human activity and human beings through a lot of measures, the national, subnational, international level, or global level, at the local level. We are taking a lot of measures to reduce the greenhouse gas emissions, so that the increase in temperature will be 1.5 degrees centigrade only. Thank you.